Recent research has shown the superiority of physical keyboards for text entry in virtual application, where a user is practically blind to the real world. Most of these works represent the keyboard by a virtual model of similar geometry, carefully fit to lie at the exact location of the real keyboard is. However, virtual reality can extend a physical keyboard appearance and repurpose it for more than plain text entry. The first fundamental dimension of the space spanned by reconfigurable physical keyboards is its input mapping. We consider three input mappings. The first is a direct mapping of a physical key to a single action. The second is to map multiple physical keys to one single action. The third input mapping maps the whole keyboard as a touch surface and a single physical key as a single coordinate. We consider three characteristics emerging from the output dimension. First, output can be revealed by augmenting a single key in VR. This allows individual keys to take on specific visual functions. Second, output can be generated by augmenting the visual display on and around the keyboard. For example, several keys and the space between them can be mapped to displaying a single user interface element, such as a photo. Third, the keyboard geometry itself can be transformed into a user interface control with different characteristics. We chose applications that sample the space spanned by the input and output axes. To support efficient graphic symbols entry using a physical keyboard, we enabled entry through processing a modifier key, for example Control, that switches the normal keyboard mapping to an emoji set. The emoji set can be changed by pressing the modifier key and the page up and down button. For writing in multiple languages, the respective character mapping can be visualized on the virtual keyboard. Further, special characters such as umlauts can be entered by first pressing modifier key, in this case Alt, and the respective letter using one hand. Then the neighboring keys are highlighted in green and will temporarily show available umlauts. Keyboard shortcuts for application have the benefit of triggering action fast, but at the cost of memorizing these shortcuts. We implemented shortcuts for a virtual web browser. Specifically, we implemented navigation shortcuts like back, forth, home, refresh, cancel, and access to 10 bookmarked web pages. While keyboard shortcuts are often reflecting a predefined set of actions, new application actions can also be defined. We define macros in Microsoft Words like insert signature, insert sender's address, and insert an image, and map them to individual keys on the virtual keyboard. Various schemes for switching open applications have been proposed for Windows managers. In VR, it is possible to visualize and access open applications directly on the keyboard. Similarly, browsing and selecting photos can be achieved. In virtual photo browsing application, a set of available photos is mapped to the keyboard. The number of photos to be visualized at once is limited by the number of physical keys on the keyboard. Further photos can be shown when buttons such as page up or down are reserved for toggling between photo sets. Beside productivity tasks, the keyboard can also be utilized for leisure applications. We implemented the game by turning the keyboard into a virtual playground, enable fast and natural interaction. When engaging with a physical keyboard while wearing an immersive head-mounted display, users can become unaware of their surroundings. This can become critical when users enter sensitive data such as passwords. To minimize those risks, we implemented 3 different key randomization strategies, which offer varying trade-offs between guessability of the pressed key by an over-the-shoulder observer and discoverability of the key by the virtual reality user. Using virtual reality, ordinary physical keyboards can be turned into quasi-touch keyboards. While they lack the input resolution of actual capacitive sensing, they have potential benefit of 3D content visualization. We implemented an application for controlling a SIG bar of a virtual video player. In order to increase the input resolution of the virtual touch bar keys, user can press 2 adjustment buttons to select an intermediate frame. Virtual reality allows to change the visual representation of individual keys or the whole keyboard. We implemented one row keyboard that is complemented by a colored bounding box indicating the geometrical bounds of the whole keyboard. A further variation, completely hide the keyboard and replace it by a relevant graphic user interface for the task at hand. Such applications are just examples of ways that virtual reality can extend functionalities of real object tools beyond their original design. Please see the paper for studies and results.